class, welcome back to Algebra 1. Today we're going to work on section 1.9, which is greatest common factor and least common multiple. But first, can you tell me what the mouse's favorite game is? Well, that's simple. It's hide and squeak. So, if you're using Bob Jones Algebra 1, we are on page 35. This says once you've factored numbers into primes, you can easily find the greatest common factor and the least common multiple of these two numbers. The GCF is used to simplify fractions. To rename a fraction in lowest terms, divide the numerator and the denominator by the GCF of the two numbers. So what is a GCF? Remember your GCF, that's called the greatest common factor. And you're going to use the greatest common factor lots. And what the greatest common factor actually is, it's the largest possible integer that will divide evenly into any two integers. Largest possible integer that divides evenly. That's not how you spell evenly. Into two other integers. Now this should be review for you. You learned to use the greatest common factor when you were reducing fractions. For example, if you had 4/3, I actually mean to say 4/6. You know that 4/6 is not the lowest reduced form of this fraction, because 4/6 actually reduces to 2/3. So what you would do to solve this is you have prime factored the 4, 2 times 2, and you've prime factored the 6, 2 times 3. And you cancel out your greatest common factor. The largest factor that each of these two numbers, number 4 and number 6, have in common, which then gives you the reduced form of this fraction, which is 2/3. So this is what we're going to be working on in section 1.9. That's using prime factoring to determine both the greatest common factor and the least common multiple. And there are two different ways that I think of immediately off the top of my head that I can use to find the prime factorization of a form. So example number 1 says, find the GCF of 18 and 56. So we have 18 and we have 56 that we want to find the greatest common factor of. Now, remember we said the greatest common factor is the largest positive integer that divides evenly into two numbers. Your book also tells us that the GCF of two numbers is the product of the prime factors that the numbers have in common. So what that means is you have to be able to write each of these numbers that you're trying to find the GCF of as a product of primes. Well, what factors can we use first to come up with 18? Well, we can say that 18 is 1 times 18. I need to grab my eraser. 18 is 1 times 18. 18 can also be 2 times 9. 18 can also be 3 times 6. And those are the three groups of pairs of factors that will multiply together and give us the result that we're looking for, which is 18. But 18 is not a prime number, 9 is not a prime number, and 6 is not a prime number. And in order to find the greatest common factor, we specifically have to find prime factors only of these numbers. So there are two ways that I think of. All of you have probably used both of these methods for finding prime factorization of numbers. Use this factor tree and you think, okay, what numbers can I come up with? What two factors, when I multiply them together, give me 18? 3 times 6 is 18. Is 3 a prime number? Yes, it is. As soon as you end up with a prime number, you can circle it. Is 6 a prime number? No, 6 is not. So you can factor it further into a 2 and a 3. So now, if we multiply 3 times 2 is 6, times 3 is 18, we have divided, or we have factored 18 out so that it's a product of prime factors. So we're going to write that 18 is equal to 2 times 3. We're just going to write each prime factor that occurs in this factorization once, but we're going to use exponential notation to indicate that 3 is used as a factor twice. Here we have that 18 is equal to 2 times 3 squared. This is the prime factorization of 18. Now, I grew up learning how to find prime factors of numbers by using upside down division. Start with the lowest prime factor that will go into the number that you're factoring. And I believe that some people also call this the ladder method. 2 divides into 56 28 times. Can I use 2 again? Yes. 2 goes into 28 14 times. 2 goes into 14 7 times. These numbers, factors out here that are on the outside of my ladder or my upside down multiplication are the prime factors that when you multiply them together you end up with 56. So you have 56 is equal to 2 used as a factor 3 times, 2 cubed, times 7. 56 is equal to 8 times 7. You learned that when you were learning your multiplication facts. Now, we want to know what the greatest common factor of 18 and 26 is. Remember, this says the greatest common factor is the product of the prime factors that the numbers have in common. What factors do the numbers have in common? Well, they have a 2 used as a factor 1 time. So the GCF of 18 and 56 is simply 2. There's no other factor that these two numbers have in common. Okay? Let me grab this pen that I threw on the floor. And let's look at the bottom of your book and see what this says, finding the greatest common factors. There are steps here. I'm going to go ahead and write this down for you. Make sure that you understand the process. This is how you find the greatest common factor. First, you're going to factor each number into the product of primes only. It's essential that you factor each number so that the only factors are prime numbers. We don't want a stray 6 in there, or a 10, or a 4. We only want prime factors. And furthermore, this is what you want to do. You want to show that factorization in exponential form. So we're going to write in exponential form. That's important. In exponential form. The second step is circle each factor common to both numbers and determine the highest common power of each factor. Determine the highest common power of each factor. Now, with that example that I just showed you, we had that 18 was equal to 2 times 3 squared, and we had 54 was equal to 2 cubed times 7. So what's the highest common power of each factor that they have in common? The only common factor is a 2. 3 is not a common factor. 7 is not a common factor. And the highest power that these two factorizations had in common was just a single power of 2. So the greatest common factor of those two numbers was simply 2. Okay? Find the product of the common factors found in step 2. And this is all there is to finding the GCF. I'm not particularly pleased with this lecture because I'm having to look at the board so much to write these words, but this is a process that you should have already learned before you made it here at Algebra 1. This is a good written review of how to go ahead and find the GCF. If you can't find the greatest common factor comfortably, make sure that you do lots of practicing. Let me go ahead and do example number 2. In the book, they use the upside down division, so I'm going to use factor trees. We want to find the GCF, the greatest common factor of 720 and 840. Now your text doesn't use this notation, but that's what this means. It just means find the greatest common factor of these two numbers. I'm going to start with 720, and I see right away that 720 factors into 10 times 72. 10 is 2 times 5. What is equal to 72? Let me see. 6 9s, 7, 8 9s. 8 times 9 is 72. Is 8 prime? No. 8 is 2 times 4. 4 is 2 times 2. Is 9 prime? No. 9 is 3 times 3. Now let's go through and circle all of these factors that are prime. 2 is prime, 5 is prime, 2 is prime, 2, 2, 3, and 3. Now we want to write the prime factorization of 720 using exponential notation. So we have 720 is equal to 2 times 3 times 5. How many times is 2 used as a factor? 1, 2, 3, 4. It's 2 to the 4th. How many times is 3 used as a factor? Twice, times 3 squared. How many times is 5 used as a factor? Just once. So I have 9 times 5 is 45. 45 times 2 times 2 is 4 times 2 is 8 times 2 is 16. 45 times 16 to 70. To 70, 450. Add that together, and you see that we have factored this problem correctly. Whenever you find the prime factorization of a larger number, go ahead and write back and make sure that your factorization actually gives you the result that you're looking for. So, we have prime factored 720. Now, let's see what we have if we prime factor 840. My mind immediately sees that we have that same factor of 10 that we did before. Now my mind sees 4s. So I have 4 times 21. Now, when you're factoring, do you have to see the exact same pairings of factors as I do? No, you don't. It just happens to be the way that I see these. 2 times 2, 3 times 7. Now let's look at this. 2 is prime, 2 is prime, 3 is prime, 7 is prime. 5 is prime, 2 is prime. So, this says that we have not 720, but 840 can be written as a product of 2 times 3 times 5 times 7, 4 separate distinct prime numbers. Let's see how many times they're used as factors. The 2 is 1, 2, 3. The 2 is used 3 times. The 3 is used once. The 5 is used once. And the 7 is used once. So here I have 8 times 15 times 7, 8 times 105. 8 times 105 is 840. So I've done the multiplication correctly. I've done the factorization correctly. Now, what I've done is I have the prime factorization of both of these numbers. Now what I'm looking for is the prime numbers that they have in common, the highest power. The greatest common factor is equal to 2 cubed times 3 times 5. They have a factor of 2 in common. The highest power that they have in common is a 3. 2 to the third power, 3 to the first. Only one factor of 3 is what they have in common. Only one factor of 5 is what they have in common. They do not have a factor of 7 in common. So the greatest common factor is 8 times 3 times 5. 8 times 5 is 40 times 3 is 120. So let's see if this really does reduce. $720 divided by 120. 6 becomes 720. See, 840 divided by 120, 7048. So 720 is 6 times 120. 840 is 7 times 120. So you cancel the largest common factor, and if we were going to be reducing a fraction that looked like 720 over 840, that would reduce down to a greatest common factor. To a fraction in lowest terms of 6/7. Now I added some things into what's going on in your book, but this is how you would be actually finding the greatest common factor of something. Now, what they want to review is the least common multiple. So let's see what we want to do with the least common multiple. Least common multiple on page 37 says this is the smallest possible integer positive integer, smallest possible positive integer that is a multiple of two other integers, or two other numbers that is a multiple, and now I feel like I have to sneeze, multiple of, excuse me, of two other numbers. What's nice about finding the least common multiple and the greatest common factor is that both of them involve prime factorization. So example 3 says find the least common multiple of 12 and 42. Least common multiple of 12 and 42. First you have to prime factor 12. You have prime factor 12 enough to know that 12 is equal to 2 squared times 3. If you don't, go ahead and practice your prime factorization. 2 squared is 4, times 3 is 12. 42, well 42 is 6 times 7, so it's 2 times 3 times 7. 2 times 3 is 6, times 7 is 42. 42 is 2 times 3 times 7. What I've done here is I have a prime factorization of each one of these numbers. We've written them in exponential form. Now what we're going to do is, to get our least common multiple, we're going to write the largest exponential form of each factor. 2 squared and 2, that's 2 squared. 3 and 3, just 7. That's 4 times 3 times 7. 12 times 7 is 84. So according to using this method of finding the least common multiple, by prime factoring, we end up with the least common multiple of 84. Let's go ahead and take just a second to physically write out some multiples here. We have 12 and 42. 12 times 1 is 12. 12 times 2 is 24. 12 times 3, 36. 48. 12 is 60. 72. And then 84. These are multiples of 12. Times 1, times 2, times 3, times 4, times 5, times 6, times 7. Well, what are our multiples of 42? 42 times 1 is 42. 42 times 2 is 84. So you see that the first time we have the same number listed in multiples of 12 and 42, it's 84. Okay? That's how least common multiple works. Let me do this last example problem for you from page 37. We want to find the least common multiple of 63 and 82. 63 and 82. 7 times 9 is 63. 3 times 3 is 9. So the prime factorization of 63, I don't want to write that as a 9. I want to go ahead and write that as a 3 squared. 3 squared times 7. Then I have 82. What I see here is not a whole lot. 2 times 41. Now I said at the beginning of the class, at the beginning of the year, that I'd like you to memorize your prime numbers up to, the first 10 or 12 of them. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. As it turns out, 41 is also a prime number. So we are going to have a very large least common multiple. 82, written as a product of primes, is 2 times 41. So the least common multiple of those two is 2 times 3 squared times 7 times 41, which means these two numbers multiplied together, which is 5,166. Sometimes your least common multiple is fairly small, sometimes it's fairly large. And that's all that you have to worry about for least common multiple, except I want to do one last thing. I wrote out for you these steps to follow when you're finding the greatest common factor. Let me write out the steps for finding the least common multiple. So write yourself some version of these steps so that you can learn and have imprinted in your mind how to find both the greatest common factor and the least common multiple. First, you want to prime factor both numbers. And then you want to write that prime factorization in exponential form. Write in exponential form. Secondly, what you want to do is circle the highest power of each factor. This is not of the highest power that they have in common, but this is circle the highest power of each factor. Remember when we came up with that 5,166 being the least common multiple of our last problem? We had factors of 7 in one number, factor of 41 in another number, but we still had to use them. So we're going to circle the highest power of each factor, and then you find the product of all of the circled factors. In other words, multiply them all together. Circle, that just doesn't look right, of all of the factors that you have circled. And that's the end of section 1.9. And I realize these first couple of weeks with Algebra 1, you probably feel like I've been teaching you like a fire hose. I'm spraying to go or a machine gun, whatever. Yes, there is a lot of material that you've had to cover, but this should be review for you. If you've forgotten some of these things over the summer, or if you were never particularly comfortable with them to begin with, now is the time for you to get very comfortable with them, because you don't want to get behind in algebra, you don't want to start slipping underneath the water. If you're having difficulty, let me know so that we can correct the problems right now. Once you're done working on the problems for 1.9, go ahead and do your Chapter 1 review, because you'll be having a test on it shortly. I'll talk to you later. Bye.